All right, so if we look over here, geometry on Monday. It's not Married Monday because it's not the first Monday of the month, but the 24th of August. Second funniest day this month, guys. Tomorrow will be the funniest day of the month. SWBA students will be able to find lengths by using the distance formula and segment bisectors. So we're going to use this distance formula and some segment bisectors. We're going to learn the distance formula today. You guys are going to love this formula, okay? And that is sarcasm. Okay? Hey, do you think it sucks? That's hurtful to the formula. Okay? Distance. We talked about distance a little bit. It's also called length. They're the same thing. The distance of something or the length of something. And it's always represented by a positive number, right? Distance cannot be negative. We talked about that last time, remember? And I said just because you walk backwards doesn't mean you go negative steps. Okay, you still took that many steps, just you took them backwards. If I drive back from Bellevue to Plattsmouth, it is not negative driving. Okay? So to find the distance between, when we found distance just between a straight line, like on our homework, if it was just straight up and down, or straight left and right, we could count, couldn't we? Okay? Or we could just subtract two numbers. But now,
actually,
if it's between 2 points on a coordinate plane, holy cow, I need to make this blank longer. 2 points on a coordinate plane. We'll use the distance formula.
I think I'm below sea level.
Okay. So if it's between 2 points on a coordinate plane, we use the distance formula. What this means is if it's not perfectly left and right or perfectly up and down. Okay? Now the distance formula is, so for example, we would need to do it between this point and this point. We can't just count this. We can't just say 1, 2, 3, 4, 5, 6. It won't work that way. Okay? So d, lowercase d, is our distance. D equals the square root of this long thing, x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. And it's the square root of all of that.
Oh my gosh.
So go ahead and write that down. What was that?
Marty not liking.
Perfect. My goal as a math teacher is to make the students cry, so it looks like we're on the step.
Well, you're never going to make me cry because I can't practice at hurts.
Okay, so.
My brain's already starting to hurt.
Good, good. D is equal to the square root of x squared minus x1 squared plus y2 minus y1 squared. Now, let me break this down for you guys a bit and see if maybe it makes a little more sense this way once I start talking about it more in this. x2 minus x1. So between 2 points, you subtract the x values. You find out how far the x's are apart. And you square it. Then you do the same thing with the y's. You find how far the two y values are apart by subtracting them. Then you square it. You add them together. And then you square root. Okay? Maybe that makes a little more sense. Maybe it doesn't. Okay? Even if it made sense for one of you, that's awesome. And then on rounding, we're going to be rounding the nearest hundredth a lot. Now we have this thing, it's these little squiggly lines. It's like equal signs, okay? But it's like you're not very sure. Like equal signs, like those are firm. You're pretty sure in it, okay? But this squiggly, it means approximately. You're like, yeah, I'm not super sure, okay? Equal signs, nice, straight, firm, okay? You're very sure in it. These are like, I don't really know, okay? It's approximately. It means it's close to. It means you round it. It means you round it. So when we're going to be rounding, we'll put that it's approximately something, but when we're not rounding, we're going to say it's exactly equal to. Okay, if that makes sense. So now let's actually do the distance between these 2 points. We're going to actually do the distance between these 2 points. So we have x2 and x1, y2 and y1, and we have our 2 points, meaning we need to label one point x1, y1, another point x2, y2. We need to label one of these points x1, y1, the other x2, y2, and it actually does not matter which one's which. Schroeder, which one do you want to call x1, y1?
3 and 4.
Okay, so we're going to call this one x1, y1. So we're going to label that x1, comma, y1. Meaning 3 is now x1 and 4 is now y1. meaning this one would be x2, y2.
I did it because it'll be much more easier.
Cool. So now we're going to plug it into this formula. So d's are distance, which we're finding. And it's a square root of all of this. So x2 minus x1. What is x2?
-3.
-3. Very good, Ray. Minus, what's x1?
3.
3. We're going to put it in parentheses,
Or I did it the other
and
way
we're going
around.
to square it, okay?
I did the other way around. Sorry.
Okay, that's fine. We'll talk about this. Okay? So far, I have written the first part of the formula. And Ray just helped me plug in x2 and x1. You just plug those in, we replaced them. Everything else is the same in the formula. Now we're going to put this plus sign because that's what comes next. And now we're going to do the same thing we did with the x's and subtracting them, but with the y's. So we do y2 minus y1. What's y2? -2. Minus, what's y1?
4.
4. And we're going to square it. And we're going to close off our square root. Now you don't actually have to put this bar at the end of the square root. It's a preference thing. I prefer to, because then I know everything before it is in the square root and this is the end of it. Okay, sometimes it just helps it be a little bit clearer. You don't have to, okay? You'll see some people write it with it, some people write it without it, okay? So now, I'm going to have you wait shorter.
Never mind. It's not important.
Okay, cool beans. So now we're going to go through our math. So according to order of operations, what comes first before everything else? Parentheses. So do we have some things in parentheses here?
Yeah.
Yeah, so what's -3 minus 3? That's in parentheses.
-6.
-6. Very good. It becomes more negative. So we have -6, and it's still being squared. Can we also do this set of parentheses?
Yeah.
Sure, they're separate. What's -2 minus 4?
-6.
-6. That's being squared as well. Okay. Now, according to order of operations, what would come next?
Exponent.
Exponent. So what's -6 being squared? What's square mean?
36. Times by itself.
Times by itself. So -6 times -6, which is 36,
36.
like Ray said. And it's positive now. It's positive. Because a negative times a negative is a positive. Okay? Plus, well, hey, do we have the same exact thing over here? -6 times -6? So we know that's 36 too, don't we? Okay? So according to order of operations, what comes now? Atom. So what's 36 plus 36?
112.
Try again.
Oh,
72.
Sorry.
72. So we have distance is the square root of 72. Now, do you guys know what the square root of 72 is
32.
off the top of your head?
32.
Okay, it's a little bit over 8. Okay, we'll talk about it more, but do you guys know exactly what it is?
32.
No, now if I said the square root of 64, would some of you know?
Yeah.
What is it? That's 8. Okay, now if I said the square root of 81, would you guys know?
9.
9, okay. But if I say the square root of 72, we wouldn't know because 72 is not what we call a perfect square, okay? What I want you guys to do is get out your phone. Get out your smartphone. Yes, I'm telling you to get out your phone right now. Okay, just on the phone, go to the time calculator. Okay.
I do.
Yeah, what's the question? I think it's positive. Okay. Okay. Raise your hand if you don't have a calculator on your phone or don't have a phone with you. Okay. Raise your hand if you need a calculator. I want everyone to have one. Raise your hand if you don't have one.
Mine doesn't work like
Okay.
that. So I need to.
Okay. Yours will work.
No, it doesn't. It has. It's not working here.
I'll show you how to do it. Okay. Anyone else? So just Ray and Dayton. Okay. Leave these in the bags. Hey, leave these in the bag. I'll get you this one, Dayton. That's a little bit shaky. Okay. Leave these in the bags, and that way I can wipe down. You can wipe down the bags afterwards, or not wiping down the actual calculator.
I'll give you 6 digits at a time.
Okay. So depending on what phone you have, okay, I'm going to give instructions for both. This is for whoever has an iPhone. This one's for whoever has an iPhone. Listen to this now, okay? If you don't have an iPhone, tune me out for a second. This is your one time I give you permission to tune me out, okay? If you have an iPhone, pay attention. What you have to do is you have to turn off your portrait orientation lock. So if you have your phone locked into being straight up and down, you turn that off. Then you turn your phone sideways. So on the iPhone, you turn your phone sideways, okay? So then you would type in whatever you're taking the square root of. You type in 72. Okay? You type in 72. Then what you'll do is you will do 72, then you'll type in, there's this little button on the far left, go one more in, second row from the left, halfway down, the button looks like this, with a little 2 there. Make sure you push the one with the 2, okay? So second row from the left, right in the middle, push that button after you have 72 in there, okay? Write down the number you get to 2 decimal places, to the nearest hundredth, okay? So those with iPhones, turn your phone sideways, 72.
Wouldn't it be 172?
Nope, just 72, 36 plus 36.
Oh, what?
And then you would hit this button, which is second row from the left, halfway down. Yes, Seth.
You accidentally press the X1, that makes it like 0.0 something.
Yeah, if you push a different button, you'll need to restart, okay? Questions on the iPhone. Questions on the iPhone, how to do that. Okay, those with the iPhone, I'm actually going to ask you to download a different app moving forward. That will help you even more, okay? That will actually be better function than the iPhone calculator, fun fact, okay? It's called Calc84. Calc84. If you want to download it now, you can. It is free with in-app purchases, so it's free. You guys know what that means, okay? Schroeder, what's your question?
I can't download anything on my phone.
Okay, that's okay. You can use the iPhone 1. I'll show you that. Now, here's for anyone without an iPhone, okay? So any Android, Google phone, so on, blah, blah, blah. You guys can phones are Androids, okay? Or the scientific calculators I give you, okay? Here's what you would do. You would type in the square root button, okay? The square root button. So if you turn your phone sideways on a phone, or if you have one of my scientific calculators, you'd have to hit second up on the top left. You'd have to hit second, and then on the far left of this, far left, right next to the 7, you see an x squared button. You see an x squared button. If you hit second and then x squared, you get the little square root symbol that's in the lighter font right above it. Do you see that? How's in the lighter font right above x squared?
This one?
Yep. So yep, you're on square root, okay? So then you hit the square root button. It looks just like a square root, and then you type in 72 and hit equal. Is anyone with this kind of phone having questions? Okay. So you push the square root symbol. Yep. And then you type in 72. And you hit enter. Okay. So anyone with this kind of phone having any questions? Yes.
You should Calc 84.
Calc 84. Yep. Yep. Okay. Yep. Yeah, you're good. Anyone else with this kind of phone having questions or my scientific calculator? Ryan, did you get it? Yep.
I don't know if I did it right.
So you did this twice. So push clear. Oh. And then just do second. Yep. Yep.
Here.
Yep.
Here.
Yep.
Equal.
Yep. Yep. All right. Anyone? Yes.
I don't know if this is correct, right?
Yep. So push enter. Okay. So the fun fact: the iPhone calculator is not amazing. It's okay. Okay. But the Android calculators are actually really, really good. They're almost as good as the scientific calculators I have in my room. Which is why if you have an iPhone, Calc 84 is a really, really good option. If you have room on your phone to download apps and you're able to, I highly suggest Calc 84. It's pretty good. So now, if you round it to the nearest hundredth, aka 2 decimal places, you would get 8 point what?
49.
8.49. Okay, 8.48 something, like a 7, I think. So it's rounded to 8.4885. So rounded to 8.49. So our distance is equal to, it actually equals the square root of 72. Now that is approximately 8.49. So depending on what I'm asking for, if I ask for, hey, what is it rounded to the nearest hundredth, I want you to put this bottom answer. If I say, what is it exactly, then I want the top number. As soon as you round, it's no longer exactly 8.49. It's almost that. Okay? Let me take that headphone out, please. Questions on that? Okay. So once again, iPhone, you have to type in the number first, then hit square root. Every other device for scientific calculator, which is what the Androids have, you type in the square root symbol first. The calculator is way better on Android. Okay. Great. Yeah, go ahead. Okay. Now we're going to practice doing a couple more of these problems, okay? Now once we actually set this problem up, was the math too bad? No, it's all math we know how to do, okay? Now are there a lot of steps where we could make a mistake? Yeah, we just have to be very careful, okay? We just have to be very, very careful as we're going through it, okay? especially as we plug it in. Actually, before I start on this one, I want to point out what would have happened. Schroeder, you said you went the other way.
Yeah.
You reordered the numbers, so you put -3 second, and you put 3 first.
Yeah, I got the same
And
thing.
you stop. And then you get the same exact thing. So whether or not we did -3 minus 3, or if we flipped them around and we called this one x2, y2, don't write this down, and we called this one x1, y1, and let's say I reordered it. And I did 3 minus -3 to start. So I did 3 minus -3. You got to be really careful with your negatives, right? Plus, and then I did 4 minus -2. Once again, you got to be really careful with your negatives. What happens when I have 3 minus -3? What happens with 2 negatives in a row? Keep the first, change the sign, right? We add the opposite of what's there. So what's 3 plus 3? 6. So you still have 6 squared now. Plus, what's 4 minus -2? What happens with those 2 negatives? They both become positive, don't they? Okay, when every time you subtract the negative, they both become positive. What's 4 plus 2? 6. Okay, 6 squared. So what is 6 squared? What is 6 squared? 36. Kevin, what's 6 squared the second time? No, over here. 36 still, didn't change. Does anyone notice what's happening? Did we get the same thing at this point? So we're going to get the square root of 72. And we're going to get the same thing here. Yeah, so it didn't matter what we got. If anyone noticed, we just got a -6 being squared or a +6 being squared. But it doesn't matter, because when you square a negative number, you're going to get a positive. When you square a negative number, you're going to get a positive anyway. So it really doesn't matter which number you put first or second for our x's. No. Doesn't matter which y you put first? No. Whatever is convenient. Moving on over here. Let's look right below at example A, on number 2. Example 2A. Find the distance between the pair of points. So what you would need to do is we would need to call one of these the first point, one of these the second point. We don't care which one's which. As we get into our distance formula, which, just to recall, is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Let me say, okay, well, we're subtracting the x's. We can actually ask, hey, would we rather do -5 minus 8 or 8 minus -5? Okay? Would you rather do -5 minus 8 or 8 minus -5? Which one, does someone have an opinion on that? Would you rather do -5 minus 8 or 8 minus -5? We're subtracting the x's. Kenny?
8 minus -5.
Kenny would rather do 8 minus -5. Cool. 8 minus -5 squared. Plus, now we have to do the y's. Would you rather do 6 minus -4, because those are the y's, or -4 minus 6? Would you rather do 6 minus -4 or -4 minus 6? 6 minus -4, okay, we'll do that, Tony. 6 minus -4. We don't care which one we do, we just have to choose one of them. So go and write this down. Didn't matter which one we chose. Kenny and Tony chose these because they would rather subtract the negative. What's going to happen with these 2 negative signs in a row?
Keep changing.
It's going to keep changing, so both of them are going to become positives. All of a sudden, we don't have any more negatives to deal with. That's kind of handy, okay? So they do that with both of those. You don't have to. If you'd rather do 8 minus -5 and make a bigger negative, you can. So now, according to order of operations, the square root stays, but what do I do first in my math? Parentheses. So Landon, what's 8 minus -5? What happens with those 2 minuses?
They turn to positive.
They turn to positive, okay? And so what's 8 plus 5, Landon?
13.
13. So now we have 13 being squared. Plus, in this parentheses, 6 minus -4. Right, or what happens to those 2 negatives?
You keep change. Change.
Change, yep. And then what's 6 plus 4? 10. So then we have 10 being squared. So now we have distance is equal to the square root of 13 squared plus 10 squared. So what would come next in our math steps? Okay, Ray?
That's fun.
Exponents. So 13 squared. So 13 times 13. Kevin, Kevin, what is that? 13 times 2 is 26. What's 13 times 13? 13 squared.
139.
Nope. I'll say Kevin will get it. Kevin will get it. We did square roots last year in his class, and he was a beast with them. Okay. Tyler and Quentin were also in that class too. They did well with it. But I think Kevin was our beast in that class. He rivaled me on how good we could do them. 169. Plus, what is 10 squared? 100. We like that one. Add an extra 0. So now, what would we do according to order of operations? Add. Ian, what's 169 plus 100? Ian. 269. So the square root of 269, do we know what that is off the top of our head?
No.
No. Put it in the calculator. Round to the nearest hundredth.
And this is where I took my phone out.
Okay? Don't flirt. Don't flirt. Okay, iPhone. Oh, Calc 84. Okay, so if you downloaded Calc 84, if you downloaded Calc 84 already and you want to use that one, you'd use it, you'd follow the scientific calculator instructions. So you'd hit the second button up in the top left, and then on the far left side, halfway down, you'd hit the x squared button after you hit second, and it gives you the square root. But then you would type in 269 after it. So you had to switch over. Sorry, I didn't realize that. Okay, here we got the second button. So you did x squared. You did the white blue, which is the little square symbol. See how that's the light blue above it? Yeah, yeah. Because you see how that little square is there, light blue. So you need the white blue button. Yep, yep. All right. And Tony, let me know what you get. Okay, 16.40, okay? It ended up being like 16.40121, okay? So it rounds off to 16.40. Ooh, I was. All right, any questions on that one? Did somebody not get that? Anybody not get that? Anybody having trouble with the calculator portion of this?
So do we need those two for our answer then?
So once again, it would depend on what I ask. So if I ask for the exact, and the approximate, then I would want both, because this is exactly what it is, and this is approximately what it is. So it depends on what I ask for, okay? So just look for the instructions. Great question, Ray. Okay? I want you guys to try letter B on your own. I want you guys to try letter B on your own.
Let's go.
Where are we going? Oh, okay.
Actually, it's not bad.
Now, once you have it, or if you just have questions, if you get stuck, raise your hand, and Ms. Haswell and I will help you. Okay, very good. Yep, when you have it or when you have questions, okay?
Oh, I did.
Ms. Haswell, are you able to help?
Yes, absolutely.
Alright. You did the square, but did you square this one?
It's also
I'll change it a little bit, okay? Otherwise, that would have been right. Yes, very good.
Oh, you're going this way, okay. So then you would go 4 times 1. But if you do this one,
Oh, yes.
if you do these two together,
You square it.
you gotta do these two
16
together.
squared goes 16.
Is that what you're confused on?
Yeah, you don't need to write the square anymore because you did that operation. You think if you add it plus n anymore, you don't need to. If you square root it, you still have
But it's good that you marked them like that.
so it's just multiply.
So sometimes what I did,
Does that make
right,
sense?
so you gotta do is
I like your,
mark that
math that
out
way.
after I put it together, then I mark it the other ones together.
Oh, okay, so you actually mixed them. So you did a y and an x and an x and a y. Okay.
Yeah.
So you gotta be careful here that you keep your x's together and your y's together.
Okay. Right. So for both of them, I have to do that or no?
You're squaring. 4 squared, 4
Very good.
times 4, not 4 times 2.
Yeah, no, very good.
Okay. Now turn down. Yep. That's a common mistake.
It's gonna have to be
Two
big pause.
students by mistake.
It's gonna have to be big.
It's time that I get it.
All right, let's talk about this one up here. So somebody help me write this one out. Somebody help me write this one out. Okay? Okay, go ahead, Tony. Three minus negative 1 squared plus, and then say the second part again. What? Okay, 4 minus 1 squared. Thank you. So D equals 3 minus negative 1 squared and 4 minus 1 squared. Now, according to our now, if you have these in a different order, is that a panic? Do you need a panic? No, perfectly okay. You can take the part. The important part is you have your x's together and your y's together. You cannot mix the x's and the y's here, okay? So what happens with 2 negatives in a row here? Keep change. They'll become positive. What's 3 plus 1? 4. 4 squared plus, what's 4 minus 1? 3 squared. Okay, so what is, now according to order of operation, we do our exponents. 4 squared is? 3 squared is? 9. So now we add. Order of operation says add. So 16 plus 9 is? 25. That's a funny number. What is the square root of 25? 5. We know that one, right? It's a perfect square. Do we need our calculator for that? No. Now here's the thing. Do I need to put approximately still?
No.
Did I round it all? No, it's exactly 5. So here, you wouldn't have to circle both. It's just that this is our only answer. So here we had 2 different answers because 269 wasn't a perfect square. On the first one, we had 2 answers because 72 isn't a perfect square. But 25, that's a perfect square. So we only have 1 answer, okay? Questions on that? Awesome. You guys are killing it, okay? I would agree with Dave there, okay? The next part is probably a little bit easier here. So we're calling the midpoint of a segment. Midpoint. What's that kind of sound like it might be?
Middle.
The middle, okay? So it's the points that divide the segment into 2 equal halves, or into 2 congruent segments. Which means they're going to be equal halves because they're congruent segments. Now, if you would rather, for note-taking purposes, instead of writing out the word congruent, if you'd rather put the symbol for congruent and save yourselves time and space, do it. If it makes sense for you, awesome. If not, write it out. So if I take this and I put a little, about halfway through, and I call this point M for midpoint, and I mark these congruent, do I now know that M is in the middle of those 2 points? Yeah, I said so. Now, did it look like it might be perfectly in the middle?
No.
Maybe not. I'm not the best artist, okay? And it could be human error, okay? So since point M is the midpoint of AB, that makes segment AM congruent to what segment?
BM.
BM or MB. Does it really matter which way we put MB or BM? No, you can call it either way. BM or MB. That makes the left half equal to the right half, or congruent to the right half. Now, if these segments are congruent, if the segments are congruent, this is for the segment, that means the measures are. So that means the measure of segment AM is equal to the measure of segment BM. Once again, if the segments are congruent, their measures are equal. So this is the length, right? The length or the distance. Length and distance are the same thing. So the segments are congruent, which means their lengths are equal. We talked about that idea last class, if you guys remember. Okay? Segments are congruent, lengths are equal. Yeah, so I see a lot of people kind of flipping the page here. Another way to think about this midpoint, by the way, guys, is it cuts it in half. It cuts it in half, okay? So we're told on this next one, point M is the midpoint of segment VW. We're told point M is the midpoint of segment VW. So that means it's exactly halfway between the two, right? Okay, which we said means that these two are congruent, which they are marked to be congruent. How can I find the length of segment VM now? Anybody have any ideas on how I can find the length of segment VM by setting up an equation? Okay? Ray, what are you thinking?
4x minus 1 equals, equals 3x plus 3.
That's exactly right. Why are we able to set those equal to each other? Does anyone know?
Because they're both congruent.
They're congruent, so they have the same measure. Okay? They have the same measure, so they're equal. Okay? We don't know what the exact length is as far as the number goes, but since they're congruent, we can set them equal. So anytime you hear the words congruent, your mind should be thinking, bells and sirens should be going off in your mind saying, oh, I should set them equal. 4x minus 1 is equal to 3x plus 3. Can we use our algebra skills to solve this equation? Yeah, Bailey, what would you do first? We have a few different options. What would you do here first, Bailey? Solve it. Okay, what's that mean? Would you subtract 4x, subtract 3x, add 1, or subtract 3? Okay, you want some help from Tony? Okay, you could add 1. There's a few different ones you could do. Let's add 1 first. Okay, negative 1 plus 1 is 0. 4x is still there. Equals is still there. 3x is still there. And what's 3 plus 1, excuse me? Someone help me with 3 plus 1. 4 plus 4. Now we have 4x equal to 3x plus 4. What would we do at this point? Tony?
Subtract 3x from 4x.
Yeah, subtract 3x from both sides. 3x minus itself is 0. But I have to do it to both sides. So what's 4x minus 3x? 1x, aka just x, right? Is equal to now 4. Did we find x is 4?
Yeah.
Or were we asked just to find x?
Yep. Oh, no.
Darn it. Elizabeth, what do we need to do?
Find the length of the VM.
Yeah, so how do we do that? Yeah.
Plug in 4 for x and 4x minus 1.
Plug it in into x and 4x minus 1, because that's VM, which is what we're trying to find. So instead of 4 times x, it's 4 times what?
4.
4. So what's 4 times 4?
16.
16 minus 1 is? So the measure of segment VM is 15. So did it say in this instruction anywhere here that we needed to find x?
No.
Okay, geometry hint, guys, geometry hint. Take note of this on in your head right now. Pay attention. Geometry hint. When it says find the length of a segment or an angle or find the length of anything, which we'll learn about, you're probably going to be finding a variable first. Okay? You're probably going to be setting up an equation and finding a variable so you can plug it in and find it. Okay? Just a heads up. Okay? Any questions on this? Okay? Next we have this thing called a segment bisector. A segment bisector. So segment bisector. What does the prefix bi mean? Like bicycle? 2, okay? Sector means like a section, so a part of something. So it means 2 sections, okay? We're talking about segments here. So it's a point, ray, line, segment, or plane, so basically anything we've learned about, that intersects or cuts through or touches, intersects the segment at its midpoint. So it cuts through or intersects the segment at its midpoint. So something else intersects the segment at its midpoint. So a midpoint or a segment bisector bisects the segment. We have this word called bisecting. It bisects, which really is just a fancy way of saying if it bisects, it cuts it in half. It cuts it in half. Okay? If it bisects, it's a fancy way of saying it cuts it in half. It might be a good idea to write that down. Now here I'll draw in my bisector, okay? So we have our midpoint M between A and B. And I'm going to have a line come through, or a segment come through. I'm going to have segment CD come through, okay? And let me actually redraw this a little bit. Now, is M exactly halfway between C and D?
No.
No, it even looks like it's not, okay? But M is halfway between A and B. With A and D. Which tells us that segment CD is the segment bisector, or is the bisector of segment AB. AKA, this first one is cutting the second part in half. This first thing is cutting the second thing in half. It's bisecting it, which means it's cutting it in half. So segment CD comes through and cuts segment AB in half. So that would make segment AM congruent to what segment here?
BM.
BM, same kind of scenario we had last time. Instead of just the midpoint, though, we have a segment going through it, added to the midpoint. And so this would again mean that the measure of segment AM, is equal to the measure of segment BM. Once again, if the segments are congruent, the measures are equal.
Why do you put the M right next to it?
The little m just means measure. Yeah, great question. So it's just saying the measure of it, because that's telling us it's a number. So maybe the measure is 5 or 7. Okay. Okay. All right. So right below this. Okay, measure segment AM, measure segment BM. So on example 4, we're asked to identify the segment bisector of segment PQ, then find the measure of MQ. So what's cutting segment PQ in half here?
Line L.
Line L. Okay, it is a line because it has the arrows, and we're told the lowercase letter L. So what's the segment bisector? I'm going to abbreviate it as SEG-BIS, segment bisector. The segment bisector here is line L. You can write out the word line if you want, and then put the lowercase l, or you can put the line symbol above the lowercase l. So if it's bisected, we know these are congruent, so could we find the measure of MQ?
Yes.
How would we do that? What equation would we need first, though, since it's cut in half there? Elizabeth. So MQ, or PQ is cut in half.
Would it be right? 5x minus 3 equals 11 minus 2?
Yep, that would be the equation. Because the whole segment was cut in half, these two are equal halves. So they're congruent, so we can set them equal. Congruent tells us to set them equal. 5x minus 3 equals 11 minus 2x. If we solve this equation, one thing I like to do is get all the x's together. So I'm going to add 2x to both sides to move it closer to the 5x. Two, 5x plus 2x is 7x minus 3 is equal to 11, and negative 2x plus 2x is 0. I got all my x's together, now I need to get the constant away. I'm going to add 3 to both sides. 7x is now equal to 14.
I'm confused.
How do I get set x by itself? Schroeder?
Right, by 7 on both sides.
Divided by 7. What is x equal to now?
2.
2. Am I done?
No!
Not quite. I need to find the measurement of MQ, so I need to plug it in. So instead of 11 minus 2x, it's 11 minus 2 times
2.
2, because x was 2. What is 2 times 2?
Minus 4.
4. Don't confuse that with what a ballerina wears, 2, 2. 11 minus 4 is 7. So the segment bisector is line L. And then we also know that the measure of segment MQ is 7. So that would be our answer. We were asked to find both of those things. Segment bisector, line L, as well as the measure of that segment. Any questions on that one? Okay, we're actually going to skip the next example.
Oh,
Okay, we're going to skip the next example for now.
don't cross it out.
Okay. You guys can. We're going to learn about the midpoint formula. We have a formula to find the midpoint. This one, not as bad as it looks. Okay? So in order to find the midpoint on a coordinate plane, the point in the middle of two things, you have to find the x-coordinate, which is going to be the averages of x1 and y, and x1 and x2. So it's going to be the averages of the x's. How do you find the average of something? Does anyone know? Schroeder.
You take the biggest and the largest and divide it.
No, not necessarily. Okay, Ryder.
You take all the numbers and divide them by how many there are.
Yeah, you take all the numbers, add them together, and you divide by however many they are. Okay? So in this case, to find the averages of x1 and x2, we're going to add x1 and x2, and we're going to divide by what?
2.
2, because there's two things added. The y-coordinate's the same thing. It is going to be the averages, but instead of the x-coordinates, it's going to be y is going to be averages of y1 and y2. Once again, you'll take y1 plus y2 and divide by 2 because you're adding two things together. Now, whatever x1 plus x2 divided by 2 is going to be our x-coordinate. This is kind of written as a point here. This is written as x comma y. This is written as x comma y. There's a comma there. So whatever you get as the average of the x's, x1 plus x2 divided by 2 is our x for a midpoint. And whatever you get for the average of the y's, y1 plus y2 divided by 2 is going to be our y-coordinate. Questions on that? Okay, let's turn the page and do a couple of these examples, okay? On A, find the coordinates of the midpoint. We're told the endpoints of the segment are 4, 2, and 1, negative 3. In order to find the midpoint, we need to do the averages of the x's in order to find the x, and then the averages of the y's in order to find the y's. So how would I find the averages of the x's?
4 and 1.
Add 4 and 1. I'm going to add my x's, okay? Our formula said a moment ago, x1 plus x2, we need our formula, over 2, comma, y1 plus y2 over 2. Well, x1 could be 4, and x2 could be 1. And we'll divide that by 2. That's going to be the average of those two.
2.2.
Okay?
2.5.
Okay? We'll get there in a moment. We'll do the same thing with the y. So which one? So we need to add 2 and negative 3. And we don't care about the order because we're adding. So we'll do 2 plus negative 3. Can someone tell me why I put 2 and negative 3 over here on this right fraction? Can somebody tell me why I put 2 and negative 3 here? Okay, Elizabeth. Keep changing. No, not necessarily. We'd have the negative 3 from this. Because those are which coordinates? The x or the y's?
The y.
The y's. And the y's go second in our coordinate. X comma y. That's what this comma is here. And just to make sure we keep this as a point. What is 4 plus 1? 5. 5 divided by 2, comma. What's 2 plus negative 3?
1.
What kind of 1? Negative 1, because the negative 3 is bigger. Over 2. Now you could leave this as a fraction, or could you make it a decimal? Yeah, so what's this as a decimal? 2.5. 5 halves is 2.5. And what's negative 1 half as a decimal?
Negative 5.
Negative 0.5. So this is our midpoint. 2.5, comma, negative 0.5. And if we look over here, if this is 1, this is 2, would this be at negative 2.5 left to, or this be at 2.5 to be positive for x value? Yeah. And this is 0, this is negative 1, negative 2. Is this halfway between 0 and negative 1? Yeah, so that's negative 1/2. So is that our midpoint? Totally is. So all you have to do is you have to average the x's and average the y's. Questions on that? Right.
Can't you just like look at the n and then figure out where that's at?
So on this problem you could, okay? But great question. On this next problem though, could we still do that? On letter B? No, we totally couldn't. Do we have a graph? No, so if we wanted to find the midpoint of these 2 points, we'd do the same thing we did last time. Where you have your x1 plus, my goodness, this thing is mocking on me. You'd have x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, if you know we're finding the averages and you don't need to write all this out to do that, then don't write all this out. But if this helps you, if you need the formula, write this out. So what would I add together in order to find my new x? My midpoint of the x's. I would add our two x's together, which would be what and what? 6 and 10, the x's. It doesn't matter the order we add in. 6 plus 10, and I would divide that by 2 because we're adding that many things together, like Ryder said earlier. Comma, now I'm going to my y coordinate. So what two things I'm going to add together for my y coordinate? Negative 3 and 5, because those are the y values. I'm going to divide by 2 because that's how many things I'm adding. Now 6 plus 10 is what? 16. So divided by 2. And negative 3 plus 5 is what? 2. Thank you, Kevin. And still dividing by 2. Now, can I do 16 divided by 2? What is that, Landon?
8.
8. Can I do 2 divided by 2?
Yeah.
That is what? 1. So my midpoint is at 8, comma 1. My midpoint is at 8, comma 1. If I look, is 8 halfway between 6 and 10 for my x values? Yeah. Is 1 halfway between negative 3 and 5? It would be, actually. It's 4 away from each. Okay? Questions on that? Okay? We're going to skip example C as well. Okay? For lack of time here, for sake of time.
I did it.
Okay, cool. So on example 7, we're going to find the coordinates of the missing endpoint. So here, we're told P is the midpoint of segment EG. So here we're given a midpoint. We're given a midpoint. And we're given an endpoint. But we're missing the other endpoint. So before, we had both endpoints, we found the midpoint. Here we're going the other direction. We have one endpoint and the midpoint. We need where the other one is. So we have a couple different ways we can solve this problem. One you can solve without a graph, one you can solve with the graph. Here's how you solve it without a graph, okay? So we said that we had x1 plus x2 over 2. That was how we found our x value, right? Okay? That found our x for our midpoint, didn't it?
Yeah.
Okay, I can call it x sub maybe m. Instead of x sub 1, my first x sub 2, my second x sub n for the midpoint. Are you guys okay with that? M for midpoint? Okay, so instead of 1, 2 for first, second point, m is midpoint, so p is our midpoint here. Now what I can do is I can take this and I can plug in what I know. Do I know one of the endpoints?
No.
Yeah, so I can plug in negative 5, the x value, into one of these two x's. That's where we would put it if we had the other one. Now the other one, do I know the other midpoint yet? Or do I know the other endpoint yet? No, that's what I'm trying to find. Okay? So I have to put plus negative 5, or plus, excuse me, not negative 5 again. Excuse me. Plus x sub 2. I have to leave x2 there. I'm still going to divide by 2. And I'm going to put it equal to whatever the x value of my midpoint is. What is my midpoint x value?
Negative 2.
Negative 2. Did I create an equation that I can solve now? Yeah. And this equation is going to give me whatever the other endpoint is for the x value. It's going to give me whatever the x value is of the other endpoint. So to solve this one, that's how we set it up to solve, we would multiply both sides by 2, or by 2 over 1. Because we have to get rid of this fraction to start with. Because it's dividing the whole left side. So 2 and 2 simplify out. 2 and 2 simplify out. So we're left with negative 5 plus x squared. On the right side, we still need to multiply. So negative 2 times 2 is negative what?
4.
4. Okay. That's going to confuse us right here. Okay. Now, that's not x squared, excuse me. I miswrote that. I'm probably confusing you with that. That is x sub 2, not x squared. Same as it was here. I add 5. And what's my x2 value? 1. My x2 value is 1. Meaning that my second point is going to have 1 comma something. It's going to be 1 comma something. We just need to figure out 1 comma what. Now I'll do the same thing actually to go through this, and I'll find the y's. So instead of doing x1 plus x2 over 2 is equal to x in the midpoint, I'm going to do y1 plus y2 over 2 is equal to the y value of our midpoint. The same idea, the y value of my midpoint, the y value of an endpoint, excuse me, is 4. So I can plug that in for one of those. Plus my other y value, which I don't know, I think it's causing me lots of trouble, over 2, is going to be equal to the y of the midpoint, which is 5 in our midpoint. I know I'm speeding up a little bit here. Then we'll multiply by 2 to solve this equation. If this is too fast for you right now, keep writing it down, and then go back and watch the video to figure out what I did if you need to, or ask me later as well. I'll be free after 3 o'clock today. 2 and 2 divide out, so we're left with 4 plus y squared, or y2, excuse me, I said y squared, 4 plus y2 is equal to 5 times 2 is 10. Subtract 4 from both sides to get y by itself.
You know, you could just take.
And y is 6. My y2 is 6. So this is 1 comma 6 as my answer. My other endpoint ends up being 1 comma 6.
Where did you get the 4 and the 5?
Or from here?
Yeah.
The y values of my endpoint and my midpoint. We're going to go over the rest of this tomorrow. We're going to go over the rest of this tomorrow. Okay? I'm going to have you hold your question. Okay, I'm going to have you hold your statement then. Okay? Excuse me, next class, not tomorrow. Thank you. Okay? We don't have class tomorrow, do we? Okay. Now, heads up, guys. Okay, I'm going to give you part of a worksheet, but not all of it. I know I'm giving it out late in class. I'm sorry for that. Okay. Yes. Okay. Giving you part of a worksheet. I'm going to tell you to do part of it. While I'm passing this out, I wanted to tell you, map testing will be on Friday in EddyHad class. So make sure you have your computers charged up and you bring them for map testing on Friday. Okay. Make sure you have that ready to go on Friday. What day?
Friday.
Friday. How's the worksheet? Yep. So on this worksheet, I said you don't have to do all of it for the next class. I want you guys to do 1 through 8. 1 through 8. So I want you guys to do numbers 1 through 8 for next class. Do not cross out the rest. But just do 1 through 8 for next class, okay? Yes.